Okay, everyone. Um, Welcome. I wanted to show you again kind of some of the features and also talk to you one more time about how what we did today in class, how it is relevant to your project. So a lot of us are coming up with research questions, meaning that you can answer the questions that you have drafted in your project by Googling an article on and then reading the article and then using the information you got from Google to answer the question. But what we want you to create instead is a statistical question. And a statistical question is a question in which you have to use a data set to answer the question. Okay, so here's some examples of statistical questions. All of these statistical questions will produce categorical data sets. So for example, what is the most common color of the cars in the school parking lot? In order to answer this question, I have to go out to the parking lot. I have to record all of the cars that I see and each color. Then from there, I can create a bar graph that shows me how many cars of each color there was in the parking lot. So that is a statistical question because I have to analyze a data set to answer it. Okay? When we're thinking about our projects, it's important to understand whether consistency is relevant to the data set or not. Because if consistency is relevant to your statistical question that you're asking, then that means you need to use various measures of center to answer your question. All right, so let's go through this example very, very quickly. Let's say that I want to plan a field day and I need to rent a bouncy house for the field day. We know that different size bouncy houses have different weight restrictions, and I need to know also how many students can be in the bouncy house at the same time. So in order to make a decision about the bouncy house that I want to rent, I need to know how much students generally weigh at my school. So here's my data set of 235 students at my school. So first I'm going to create a graph. Then I'm going to drag the weights here because that's going to give me the relevant information that I need. This data looks pretty consistent because it's clustered together. It's relatively symmetrical. Okay, so I know that I can use a measure of center to represent this data set, but I want to be a little bit more liberal than just one number. I want to see if there's a range that can represent the ages for students at my school. So what is that range of weights? So I'm going to group this data into bins. So here I see that generally students at my school weigh between 80 and 120 pounds. And I want to make sure that this is not, that the gender of students is not impacting the distribution here. So I'll just go ahead and I'll drag that attribute of gender over here. All right, so it looks like it's still pretty much the same distribution. So that's all good. But let me get really, really precise so that I can figure out how many students will be allowed in the bouncy house at a time. I need to get a little bit more precise, so I need one number to represent the data set. So the good news is that, let me take these out of the bins. So the good news is that now I can find the mean for the data set. So the males at the school have an average weight of about 103 pounds. The mean of the girls at the school, the females at the school, is about 98.9 pounds. Okay, so that's pretty close together. So that's good to know. So somewhere around 100. Let me make sure. Median gives me about the same values. If I look at my box plot here, it shows me that, yep, these data sets are pretty consistent with one another. They're in the same place on the number line. They're generally the same size. So I've got some really consistent data sets. So these numbers should be good to go. So because I needed some values to represent my data set, the consistency of the data set was relevant. So when you're doing your project, based on your statistical question, if your statistical question is trying to use your data set to come down to a typical value or one value, then you're going to use this type of analysis that you see here. Okay? And these are all the things that we learned. Mean absolute deviation. The mean absolute deviation of this is 15.6. So that means most of the data sets, most of the points in the data set are 15.6 pounds away from the mean. And down here, 14.9 pounds away from the mean, which again proves that these data sets are pretty similar. And they're both the same amount of consistency. Okay. All right. Now, let's look at this example here where the consistency is not relevant. I want to start a tutoring business for students at my school, and I need to know if 6th and 7th grade math is the right grade level to focus on. So my statistical question is, what percentage of the students at my school are in middle grades? So the data that I have over here that's going to help me answer that is age. So I'm going to assume that the students that are in the middle grades at my school are 11, 12, or 13 years old. I'm going to use that as an assumption. All right, so I'm going to create a new graph. I'm going to bring it over here close to this text box so I can see what's going on. Okay, and I'm going to drag the age and years over here to this new graph. Okay, so it looks like a good amount of the data is clustering around 12 and 13, but I like to get precise, so again, I'm going to group this into bins. Okay, and I'm asking for what percentage of the students at my school are in middle grades, age 11, 12, and 13. So I'm going to do a percent, and it calculates it for me up here. So I see that 13% are between 11 and 12, are 12 and are younger than 12. Another 20% are older than 12 but younger than 13. So all of a sudden, altogether, that's a 39% of the population is 13, younger than 13. I need to extend that a little bit. It looks like I should extend it to include 8th grade if I want to make more of a profit or if I want to have a higher percentage of the population. So if I add in, it looks like I have half. I can estimate probably that half of these 13 to 14-year-olds, as we can see, the data is kind of split down the middle a bit. So this row is about 13. This row over here is a little bit older. So I'm going to just estimate about, let's say if half of this data is 13-year-olds, then 10%, oh no, I meant over here. So these kids are about 14 and a half. So about 10 of those kids are probably in the 8th grade. And then 20% plus 26 plus 13%. So at least 69% of the students in the school are in 6th, 7th, or 8th grade. So I should extend my services to include 8th grade. So this is the type of analysis that you need to do when you're looking for the highest frequency, because you want to know where you want to target. If you want to know information about a target portion of your data set, consistency is not relevant. If you need the answer to your statistical question, if it's going to represent the whole data set, then consistency is relevant, and you can use values like the mean and the median, which are measures of center, to represent your data set. And also, I hope you learned how to use some of these tools here available in CODAP.